Good morning, geometers, or good afternoon, or good evening, and welcome to another lesson with Mr. Forster. We are looking at Unit 6, Lesson 1, focusing on exterior angles. You'll notice I made a few changes from last time around making these videos, so there's no assignment or due date listed on the screen in front of you. The reason for that is these videos will be shared between myself and Mr. Swatala's class. If you're coming over from Mr. Swatala's class, welcome. We are going to dive in right away, so let's go ahead and get started. Here we have the warm-up from our lesson today, so I want you to try these on your own and press play when you are ready to check your work. So go ahead and pause the video now. Alright, on this first one, on number 1 here on the left, we're going to be finding the values of x, y, and z. So the first thing we can do is if you look at this arrow here is pointing at this left triangle. So this arrow here is pointing at this left triangle here, which is where we're getting these values, 65 from this corner here, 39 from this corner up here, and x from this corner down here. Since these are all within their own triangle, they should add up to, or their sum should be 180. And then from there, we can combine like terms on that left side to get 65 and 39 makes 104. And then finally subtract that 104 from both sides to get the value of x, which would be 76. Next, we're going to go ahead and look for solving for y, and the reason for that is x and y are collinear, which means that they will also be supplementary. And since now that we have the value of x is 76, we can substitute that value in and see that 76 plus y is equal to 180, which means that y must be equal to 104. Now that we have the value of y, we can use that and the value of 21 to solve for the value of z. So we're going to set it up much like we did with solving for the value of x. We have y and z and 21 are all part of this kind of right interior triangle here. So they need to add up to 180 as well. So y we know is 104 from our previous work. So now we have 104 and z and 21 make 180. Combine like terms to get z plus 125 is equal to 180. And finally, we subtract 125 from both sides. We get z is a value of 55. All right, let's look at number 2. So again, we can do some similar work here. Keep in mind this kind of partial red square here means that these two segments are perpendicular, which means they form a 90-degree angle. So that means that on this left kind of smaller triangle, I can say that x plus 62 plus 90 is equal to 180. I could have also said that x and 62 is equal to 90 by subtracting 90 from both sides. By knowing that, these two will be complementary when I have a right triangle like this. But this would be the other way to do it. So here we can combine like terms to get 62 and 90 to make 152. Subtract the 152 from both sides, and I get that x is equal to 28. Since this is a perpendicular here, z must also be a 90-degree angle. Again, these two are going to be supplementary by the nature of them being a collinear pair. So we can use that fact now to solve for the value of y. So we can substitute z in as 90, and we get y plus 90 plus 49 is equal to 180, which means that y plus 139 is equal to 180. Subtract 139 and get y is equal to 41. There is a way that you could have used 62, 49, and the value of x and y together. So you would have gotten the same thing if you had thought of the bigger outside triangle. But I chose to break it up into two smaller triangles here. Okay, moving on. So we have this new idea known as a corollary to a theorem. And if you remember, a theorem is something that we can prove to be true. A corollary is something that has to be true based on a theorem that we've already proven. So it's something that just kind of follows in line with whatever we can already prove. So we have this idea of the triangle sum theorem, which we used in our warm-up, which is that the three interior angles of a triangle must add up to 180 degrees. That's what this is saying here, that if I have triangle ABC, measure of angle A, measure of angle B, measure of angle C, these three have to add up to 180 degrees. Well, if I know that C is a right angle, that means that my other two angles inside of this right triangle are going to be complementary, which is that they add up to 90 degrees. And I kind of mentioned this early in our warm-up that if I took angle C, if I knew that was 90, and if I subtracted 90 from both sides, that would leave this right here, that A and B must be equal to 90. So let's apply this idea. So we'll do number 5 together here. So I've circled them. Your notes won't have these, but I've circled them in blue and red respectively. And we're going to go ahead and use that as kind of our color coordination here. So using this idea, I have this third angle here as a right angle is 90, which means that these two angles must be, rather than supplementary, complementary. So they must add up to 90 degrees. So the angle here circled in blue, that 80 minus 2x, that expression is written in blue. 70 minus 3x, that expression is written in red. So we're going to take these and we're going to set them, their sum equal to 90 degrees, and solve for the value of x. Combining like terms, 80 and 70 give me 150. Negative 2x and negative 3x give me negative 5x. I can subtract the 150 from both sides, get negative 5x is equal to negative 60. And finally, dividing negative 5, I should get that x is equal to 12. So again, this idea, this corollary idea, is something that just logically makes sense based on a theorem that we already have, which is our triangle sum theory. So the corollary is that the acute angles of a right triangle will be complementary. And again, you can pause the video anytime if I move a little bit too quickly. There should also be options in YouTube to change the play speed if necessary. Continuing on with some more of our ideas here. We're going to look at some new names of some of the different angles that we have when we have this ray that extends past our triangle. So if one of our sides, rather than being a segment, is a ray and continues on, then we have now this thing called an exterior angle. So the formal definition of this is an angle formed by a side and an extension of an adjacent side. So this side is not being extended, but this side is, and it's adjacent to, it's next to that side that wasn't being extended. And so this angle right here, this angle 1, is the exterior angle. Next, we have non-adjacent interior angles. So non-adjacent means not next to or touching. And so it's going to be the two interior angles that are farthest away from a certain exterior angle. So these angles 2 and 3, these are non-adjacent, they're not next to, they're not touching this angle 1. And they're also on the inside of our triangle, so they would call them interior. So non-adjacent, not touching. Interior angles, so they are on the inside and they are not touching angle 1. Another way you can think of this is that they are the two angles of the triangle that are not touching the exterior angle, which I mentioned earlier. So again, adjacent means next to. All right, I'm just rambling at this point, so let's move on. Exterior angle theorem says the measure of each exterior angle of a triangle equals the sum of the measure of its non-adjacent interior angles. So that's the two things that we just looked at. So that means that this angle 1 right here is going to be equal to the sum of these two angles, 2 and 3, over here. Measure of angle 1 equals measure of angle 2 plus the measure of angle 3. So we can use this as a shortcut when we are solving for different angles when we have this extension of our triangle. So here it says find x, or more specifically find the value of x. If you say find x, you might say, well, there it is, Forster. But I want you to find the value of x. So try this on your own. Pause the video, and then I will share my solution. All right, hopefully you tried that on your own. Let's go ahead and walk through it together. Here, this is our exterior angle. These are our two non-adjacent interior angles. So you can take 64 and 45 and add them together to get the value of x. And you would get that x is equal to 109, barring any minor arithmetic errors. All right, if we look at number 9 here, we can do something similar. It says find the value of y, then find the measure of angle D. So again, pause the video, see if you can figure it out, and then I will share my solution. All right, here is the way that I went about it. So I have 116 degrees. This looks a little different because my image is kind of flip-flop from above, but that's my exterior angle out here. And then these two that are marked in blue and green are my two interior angles. So I'm going to add those together and set them equal to my exterior angle. Combining like terms, I get 4y and 7y make 11y plus 6. Subtract the 6 from both sides, I get 110 equals 11y. And finally, I get y is equal to 10. If this is as far as you got, then you only answered the first part. We do still need to find the measure of angle D. To do that, we need to take this value of 10 and substitute it back into our expression for D, which is circled here in green. So measure of angle D is equal to 7 times the value of y, which is 10, plus 6, which gives us a measure of angle D is equal to 76 degrees. All right, so once again, I want you to try these on your own, and then I will share my solutions. So you have 10 says write an algebraic equation and solve for x. And then number 11, it says find the measure of angle PQS. So PQS would be this exterior angle right here. All right, I'll give you a few seconds to pause, and then I will share my solution. All right, for number 10 here, again, kind of mark these in blue and green respectively, and we'll leave this one in red. So the exterior angle, 5x plus 13, equals the sum of these two interior angles. That 4x plus 2 is this angle. That's what the little arrow means. It's the inside one here. So I'm going to add those two together, equal to 5x plus 13. And then with some algebra manipulations here, on the right side I can combine my like terms of 4x and 2x to get 6x. 2 and negative 9 make negative 7. Next, I can subtract 5x from both sides. Not the only way to do this, but this is the way that I chose to do it. And I get 13 on the left over is equal to 1x, or just x, minus 7. And then add 7 from to both sides, rather, and I get 20 is equal to x. All right, let's look at number 11 here. Once again, I have my exterior angle circled here, 3x plus 25. And then I need to add those two interior angles, those non-adjacent interior angles, 2x and 65. So 3x plus 25 is equal to 2x plus 65. And then if I subtract 2x from both sides, I don't have any like terms to combine on either side, so I'm going to go ahead and start by subtracting that 2x over. And I get 1x left over on the left, plus 25 equals 65. Subtract the 25, and I get x is equal to 40. But again, I'm not done just solving for the variable. It doesn't want the variable, it wants the exact measure of angle PQS. So we will substitute that back in. We get PQS is equal to 3 times 40, which is our value of x, plus 25, which means that measure angle PQS is equal to 145. All right, well, that concludes our video lesson for today. Hopefully you found that helpful. If you're in Mr. Swetala's class, I would strongly recommend that you check in with his Google Classroom, if he's using Google Classroom, or if he's using Teams, to check in there for whatever assignments that you have that go along with this. If you're in my class, again, Mr. Forster's class, then you will be checking Google Classroom for the assigned work that goes along with Unit 6, Lesson 1. Have a fantastic rest of your day, and I'll catch you in the next video.